All right, lesson 6-3, square root functions and inequalities. So by the time we're done with this lesson, we should be able to graph and analyze square root functions and graph square root inequalities. All right, so to start off with, a square root function, if we just talk about the parent function, is f of x equals the square root of x. And then in general, so our general equation is a times the square root of the quantity x minus h plus k. And we can do other type of radical functions. So we can do like a cubed function or a fourth root function. So this n right here, that indicates the root of the function. Okay? So if we don't have an n there, we're assuming that it's a square root function. Okay? And because we're using h's and k's again, the vertex of this, so kind of its endpoint, is still going to be the opposite of h and then whatever the k value is. So to start with, we're just going to talk about the domain and range, and then kind of what the graph looks like. Okay. So let's start with our most basic function, so our parent function, the square root of x. Now, when we graph, we can't graph imaginary numbers. So that means whatever we get inside the radical has to be positive. So for this problem, if we need x to be positive, the domain of this would have to be from 0 to positive infinity. So I can choose a number in the positive. So anything bigger than 0, I can put that in and I can find an answer for y. Now the domain then is going to depend on the type of answer we're getting after we take the square root of it. So for this problem, because we're just taking the square root of x, well, we know that we have to have a positive answer, because if we take the square root of something, it's even, so we need a positive answer. And we're not adding or subtracting anything from that. So for this one, the range is going to also be from 0 to infinity. Now I know it didn't ask for it, but let's go back and find the vertex. So there is no h and k, so the vertex for this is 0 and 0. All right, let's do another one. So again, this time I'm going to start with the vertex. So we know the vertex for this problem is going to be 3, 0. Okay. So again, if we think about our domain, we're not allowed to take the square root of a negative number. So we need to think about a number that we can put in for x, and we want the smallest number so that we end up with 0. Okay. So if I put a 3 in here, so 3 minus 3 is 0. That's going to be the smallest x value that I can use. Because if I use 2, 2 minus 3 is a negative number, which we're not allowed to take the square root of. So that means that the smallest x value that I can have for this is going to be 3, and I can pick any number bigger than that. So our domain is going to be from 3 to positive infinity. Again, our range, so the smallest number that we can take the square root of is 0. And again, I'm not adding or subtracting anything to that. So that means then that my range has to go from 0 to positive infinity. Okay. So notice how the numbers that we're using for our vertex end up in our domain and range. So that pattern is going to happen every single time. So we just need to think about if there's any reflections happening. All right, so again, if we take a look at problem 4, I'm going to start with the vertex again. So the vertex for this one is going to be negative 4, 0. So again, the smallest number that I can put in is negative 4. So negative 4 plus 4 is 0, which is the smallest number that we can take the square root of. So that means that my domain, it can go from negative 4 up to positive infinity. And again, if we choose negative 4, the square root of 0 is 0. We're not going to add or subtract anything to it. So the range is going to go from 0 up to positive infinity. So again, I'm using my x value of my vertex in the domain and the y value of the vertex for the range. All right, next example. So I'm going to start with the vertex. So vertex is 0, negative 3. So again, if we think about the domain, so again, I can choose any positive number for x. So that means the smallest number I can pick is 0. So we're going to go from 0 all the way up to positive infinity. Now this time for my range, I can take the square root of 0, but when I do that, I'm subtracting 3 from it. So that means that the smallest y value that I will be able to get is -3 this time. So it's going to be from -3 to positive infinity. Okay. So again, when I do domain and range, we're using the x value of the vertex with the domain, the y value of the vertex with the range. All right, next one. So again, vertex is going to be -5, -7. So that means our domain is going to go from -5 up to positive infinity. And then the range is going to go from -7 up to positive infinity. All right, on 6, same thing. So vertex, so there's nothing being added or subtracted on the inside. So vertex is 0, 0. So that means for my domain, I'm going to have to use 0. But notice how we have a negative on the inside of the radical this time. So when this happens, if I choose 1, it becomes a negative, and we're not allowed to just take the square root of a negative. So one of my endpoints does have to deal with 0, but for my x's this time, I actually need to choose negative numbers. So if I choose -1 and I substitute it in here, I would have a -1, which would make it a positive. So because it's a positive, I can take the square root of it. So this time for my domain, my biggest x value that I can pick is 0. So that actually means we're going to go from -infinity all the way up to 0 for the x's. But my y values haven't been affected. So that's still going to be from 0 to positive infinity.